passionate and interested in. This presentation is very flexible, so if you have any questions, please let me know. I wasn't sure the types of things that everybody would want to cover and where to go with this, because you can go very deep and also get very philosophical as well. So we'll probably do a little bit of both. But before I go there, was there anything during the movie that you saw that you were just had a compelling question in terms of the technology and what was shown?
So where can we buy one?
We'll actually talk about that. Yeah, Paul was saying right when he came in that he hopes that this technology is available soon, and in all reality, it's available now. It just might not be in the form that we all saw in the movie. It's not far out. And what's strange about talking about artificial intelligence is the things that we don't see are much further along than most people realize. So there's a lot of magic going on in terms of artificial intelligence that we interact with every day, but we don't really realize. And then the things that we expect to see, like the robots that talk to us, are probably not as important. They're probably not the most interesting part of what's going on. And so we'll get to that near the end. I want to start off in more of a kind of structured fashion where we talk about the technology itself. And forgive me if I get a little bit in the weeds. You can always stop me. But I want to at least highlight some of the things that are going on today with this type of technology. So further introduction to myself, and this is my disclosure slide, so I want to make sure everybody understands where I'm coming from and why I think I deserve to be standing up here in front of you. So I'm a member company of iGate. If you're familiar with iGate, it's just downtown, right across from the post office. It's the old AT&T buildings. There's two AT&T buildings, but this is now one of the empty ones, and there's interesting history that goes along with all of that. So there's a lot of startups there, and I'm one of the startups. We're an analyst firm / software company. Originally from Colorado. I have 2 degrees from Regis University there in computer science and mathematics. And my computer science degree was focused on quote-unquote artificial intelligence, where I spent a lot of time. And I'm leveraging the technology today, but in some kind of boring, bland ways, not like the robot in the movie. What else do I want to say about myself? I've written a lot of books on some of the artificial intelligence technologies out there around voice and speech recognition, text, object recognition, and I'm not a robot, but I wish I was. I'm not a scientist, so I'm more philosophical and theoretical. I do know the technology pretty well, but if there are any scientists in the room, that's my disclaimer. And so what I'd like to do is to create a better sense of what artificial intelligence means. What we're going to talk about, a lot of what we're going to cover today, is not necessarily in the physical world. So when we see movies like Robot and Frank, and all the other movies out there that demonstrate robots that have intelligence and appear human and act human, that's all physical, right? But a lot of what's happening in terms of what makes them tick is not physical, it's software. And probably the most powerful aspect of artificial intelligence is software. I don't know if you've seen Honda's robot. Very, very similar to what the robot looks like in Robot and Frank, and can have all the same mannerisms and pretty much, from a physical standpoint, do all the same things. Can it think like the robot? Maybe not quite yet, but that's not far off. There's only some small limitations, and they're actually relatively, I won't say trivial, but they're fundamental. So that's first goal. I want to explore the various movements inside of artificial intelligence, really contemplate what intelligence means, and call out the ways that AI is impacting us today, and also speculate on the future. So before we really get into this, I want to explore the definition of artificial intelligence, and maybe the friend I brought with me today can help. Alexa, what is artificial intelligence?
Artificial intelligence means the branch of computer science that deal with writing computer programs that can solve problems creatively.
So you can see that alone I've brought a little example of what we have today. Did everybody hear Alexa? Alexa, tell me a joke.
The bartender says, "Sorry, we don't serve faster than light particles here." A tachyon walks into a bar.
Okay, that was a physics joke. You'd have to know a little bit of physics. Most of them are pretty easy. So Alexa can do a lot of things, and we actually have her at our office at iGate. She mostly plays music, but she's also become the center of some jokes. So here's an example of technology that a lot of us would consider artificial intelligence, but actually what's going on with Alexa is not that complex. Go ahead, there was a
What does
question.
Alexa do when you're not asking her a question? Does she do the information that's going on?
Yeah, well, that's somewhat of a philosophical or somewhat of a controversial point, but she's listening constantly. But the trigger is her name, Alexa, and without that, she's not going to take any commands, but she is listening. So you could argue where that data is going, but
I'm not quite sure how to help you with that.
But if you're asking, is it being streamed to Amazon, all of the data, likely not, just from pure technical challenges associated with that, which we'll actually talk about. So artificial intelligence is actually a horrible term. It's really more rooted in marketing and film and media than anything else. It doesn't tell you much of anything. It's highly subjective, and so subjective in fact that it's manipulated in many, many ways. So I don't necessarily like the term artificial intelligence and AI, but it works very well. And one of the interesting reasons why is that we are all obsessed with finding things that are human-like. It's just in our nature. We want to identify humanness. And that's what's happening when we watch movies like the one we just watched, which, by the way, Robot and Frank is actually one of the best representations of how robotics may enter our world. If you notice, it was not that disruptive. When they walked around the downtown, it was very much like Livermore. It wasn't weird LCD screens in every windows. It was a very kind of natural, comfortable world that we were used to, but all of a sudden there was this robotic element. And so I think that is very practical, and with the exception of some small, well, large, but some things that would have to be addressed, something that could happen today. But the reason we really associate with the robot in the movie may not necessarily be what he's capable of doing. It may be the fact that we're so rooted in identifying with humanness and things that are living. We do it all the time, and I put some of my favorite characters up here that we identify as humans in their cars and airplanes and a toaster. But one of the most amazing ones is the Pixar lamp, which is nothing like a human. But just because of the movement in the big light bulb, and we see it animate and bounce, we get a sense of it being alive and real. And so this is a fallacy. This is kind of a trick that has led a lot of people to misattribute intelligence to certain technologies. And so I want you to remember that. And the way I look at this is there's a spectrum of intelligence. The first part is logical. The second step is learning. The third is adapting. And the fourth is living. And in living, I'm not talking about a soul, and I'm not talking about the things that we associate with being human. What I'm talking about are two key elements, which are introspection, being aware of yourself, and empathy, being able to associate with others and understand what others are feeling. So if you look at what's available today, and people could make an argument against this, and I know many people that would, that's why at the beginning I said that I'm a pragmatic optimist when it comes to AI. I love the technology, but realistically, we've only made it to the learning point, far beyond logical. Logic is just computers. Learning is the ability to get better as we go. When I talk about adapting, adapting is writing your own algorithm. Algorithm is just a program. Starting to create your own, programming yourself. And you could say in some respects where there is some technology that's close to being there. Most notably in IBM's Watson. Has everybody heard of Watson? And Google's DeepMind, which maybe a lot of people don't know about, and I think I'll talk about it at the very end. So if we're anywhere near adapting, that's where it's happening. But even in that case, we are telling it what to adapt. So we are telling it how to adapt, which is not really adapting, right? So I think that there's a limitation in the spectrum of intelligence of where we are today, and I think that it's going to take a long time to bridge that gap. Now the question is, was the robot in the movie at adapting? Did anybody think that the robot was at the stage of adapting? No. Yeah. Well, that's great, because I don't think so either. I think that the robot was very much in the stage of learning. Now, the robot said some interesting things that I liked. Developing trust is part of the program.
Okay.
So he was told to demonstrate trust. So that's what he did. He learned how to demonstrate trust with Frank. He lied. So that one's tricky, because one of the messy parts about being human is telling little white lies, and he did that. So that is actually an aspect that I don't think we would see in learning. I think that is more in the area of adapting. So I have some other elements I want to point out in the movie, but I'm going to stop there. Going back to the definition of AI, it's really a class of technologies. So when we say artificial intelligence, we're not really saying anything. We're classifying a group of technologies. Some are being used widely today, some aren't being used, some we only speculate about, and this is only a partial list. At the top is neural networks, then we have robotics, etc. I don't need to dive into any of them. I'd be happy to at the end. Evolutionary programming is where I participate, and I've done a lot of in what I study. But there's a lot of this that we already do today in the applications that we use on a regular basis, most notably data science and recognition technologies. And I tried to think, well, how do we visualize where we are in our daily lives and how artificial intelligence touches us? And I have that section, perceived AI. So these are the things that kind of give us the impression that they're artificial intelligence and that we are doing something really magical. But it's more of a trick. It's more of our interpretation of the technology. I'm not diminishing their usefulness, but they're not intelligence necessarily, like Alexa. Alexa is a combination of voice recognition and a whole bunch of really big databases of weather and sports scores, and she uses Wikipedia. So that's really all that's going on. She's taking my voice, which is probably the most complex part, and associating it with a search on a database, something you could do by doing a Google search. Then we start to go into the more in-depth technologies that are evolving. You see I have Google's Smart Car, Google's DeepMind, and Watson. Here, oh, I think this has a laser pointer. Yep. So here are things that we touch every day, and the Oculus is a virtual reality. There's a lot of virtual reality technology coming out right now. And it's very interesting and useful. And then we have Google itself, and we have Alexa and Siri. Then we have the smart cars. The amount of AI that's going in on the smart cars is very interesting. This emblem is the Singularity Institute. So this is an institute that runs out of Moffett Field, I believe. And it's focused entirely on artificial intelligence and transhumanism, which I'll talk about in a second. It's actually a university that has courses and so forth. And then we have way off in the distance, we have the transhumanism movement. So this is kind of where I think our world is, and we're still mostly living in the spectrum. Now you'll notice I haven't really talked about robotics at all. And that's on purpose because I think that we attribute AI only to robotics, but there's a lot of artificial intelligence already going on in our everyday lives with those technologies I just showed. And to give you an example of that, here's some things that we don't really, again, we don't associate with artificial intelligence, but they are. I'm assuming everybody uses Google and does Google searches. Well, if you were to spend a little time and try to figure out the first letter you type into the Google search bar, what's going on, it's phenomenal. It is just remarkable what's going on. Literally, an entire database is being brought to your fingertips at real time because it gives you suggestions. How do they come up with those suggestions? They're using artificial intelligence to do that. They're using neural networks, and they're predicting what they think by your location, by your behavior, what you're searching for. And at points, it's almost terrifying what the suggestions come up as. I don't know if you've just been watching TV and you decided to search something that you saw on the TV, and you just type the first letter, and the first thing that comes up is exactly what you were thinking. It's happened to me a lot, and it's really amazing. Don't underestimate what Google is doing. In my opinion, some of it is rather sneaky. People say if you're not buying from them, you are the product, and there's a reason because that Google gives you so many free things. Is for their ability to profile you, to create a DNA of your behavior. So that's brain extension, this technology. We're already using technology to be a part of us. And it happens to me in a big way. In some ways, I don't like it. Like my memory in the last 5 years has gone downhill tremendously. And I used to prepare for things in weeks in advance, and now I prepare hours in advance because all of my devices tell me what I should be doing. So I don't have to remember that. I don't have to take up storage in my brain. I use the devices to do it for me. I have a smartwatch to help tell me how my health is. And I can use this to improve myself, but I can also use it to better communicate with my doctor, which could lead to life extension. So in many ways, the technology we're already using is an extension of our brain, our memory, it's extending our health. So it's already there. But in this case, that artificial intelligence is a part of us in many ways. And so I think that that's something that we often neglect when we think about AI. We're focused over on robots and butlers, but really it's very much a part of us today. So any questions so far?
Yeah, I think that can be threat to the humanity because the machine can take over you, or the machine can mock you, or you can programming at a certain point, the machine completely against you.
Yeah, so we'll talk about that once we go down the rabbit hole. And that, we will go down the rabbit hole. But that's the philosophical, can robots take us over? All you can have is an opinion. You can't have an answer when it comes to that. But I will give you my opinion on if that's going to happen, when it's going to happen, and what it might look like. Is there another question?
Isn't there a likelihood that the advancement of artificial intelligence will make us more like robots than we are now? Because we'll end up relying on all these things to a great extent.
Yeah.
So
Yeah.
that's one thing I'm worried.
So the answer is yes. And that also is in the rabbit hole. So maybe I'll get to the rabbit hole faster than I expected. But let me, and when I say the rabbit hole, I mean when we start talking about life and in the philosophical elements of this, and will robots take over the world, I think is the question that a lot of people have in the back of their mind. But these are just some use cases, so I just put these up for fun because these are all very real things. Question was asked, when can I have the robot from Robot and Frank? Well, Mark Zuckerberg says that it's going to exist by 2016 because he's going to make his own. So if that happens, then there you go. We have it. On Kickstarter, anybody familiar with Kickstarter?
Yeah.
So right now there's the equivalent of the Robot and Frank for $1,400 if you want to back the campaign. If you've ever participated in Kickstarter campaign, about 50% of them, maybe it's probably less, are successful. So that'll tell you where it is. Has anybody gone to a website and in the bottom left corner, the bottom right corner, it says Bob wants to talk to you? Or do you have a question, please type your question here, and it acts like a real person? Yeah, so that's the same as the Robot and Frank, because it's the same type of mechanism. If you actually ask a question there, the responses are going to seem very human. You might even think there's a human on the other end, but there isn't. Those are just automated support systems that people pay money for. But that technology has been around for quite some time. And similar to Alexa, the most complex part of that technology is the language, reading the language. Because there's the matter-of-fact language that we all learn and is in the books and the computer can learn, but then there's sentiment and other things that you can't learn, sarcasm and things like that. That's the most complex element, but everything else that makes it seem human is just a bunch of databases. All right, so here's some of the things that I see coming soon, and I'm gonna fly by this. And then here's the mind benders. So I put robotics in bold because I think that that's what most of us think about when we think about artificial intelligence. And I'm going to dive into a little bit more. And then there's the transhumanism element, which this gentleman alluded to, which is computers become us, we become the computers, they replace us. There is a big group of people who believe that can happen and are working on that today. And then the advancement of evolutionary programming. When I talked about adapting, it's an evolutionary programming that's going to make that happen, and that's incorporated into robotics. All right, so that was the more tactical elements. Do we have any questions on those? Because I'm kind of fast forwarded.
You've mentioned neural networks a couple of times. Can you give a quick definition?
Yeah, this is where I really wish I had a dry wash board. I'm going to see if I can do it right here. So neural networks are basically taking direction from our brains. And if you're familiar with how the brain works, there's a whole bunch of neurons inside of our brains. There's on the order of 100 billion or some sort. There's tons of them. And they all fire at different energy levels. So it takes a certain energy level for a single neuron to fire. And it's in that firing that we start to that drives us, okay? Well, neural networks are exactly the same thing. And neural networks have been used for, oh geez, I mean, they were developed shortly after the computer was developed. It's a technology that's been around for a long time. I don't have the exact data, I wish I did. What happens is the same technology looks at a whole bunch of neurons. And these neurons receive an input of some sort. And depending on what neuron fires, oops, I'm doing my best, you get a result. So here's, the last two circles are some sort of outcome. So let's say outcome A is, I'm going to use text recognition because I know it very well. Outcome A is the letter A. Outcome B is the letter B. So if this one fires, it means it's the letter A. If this one fires, it means it's the letter B. So they're all of these neurons are tied to the output. I hope I'm not getting too crazy for you guys here. And let's say that when the middle two fire, it means it's an A. When the top three fire, it means it's a B. That's a neural network. Very simple. This is a very simple example of a neural network, and actually in principle, their structures are fairly simple. Obviously, a real neural network gets very, very large. And so I said character recognition. Character recognition is when you scan a document and it converts the image into text. So it converts the words on the page into text. You can edit. That's using neural networks exactly like I showed here. And it has these neurons that just all fire at different impulses. If it's a white square in the image, it fires at 0. If it's a black square, it fires at 1. And that's how it works. It just, in a grid like this, these are a whole bunch of zeros and ones. And that's it. And that's all everything in computer science breaks down to, zeros and ones.
So are the neural nets mainly used for some kind of pattern recognition?
Well, I guess you could say it's all pattern recognition, but neural nets are used everywhere. And so in Google search, it's using neural nets every time you do a search. In voice recognition, not so much. In text recognition, it's using neural nets. So yeah, it really is more associated with pattern detection. And it's used a lot today when we analyze behavior. Like if we want to analyze the behavior of cars and identify patterns of cars. Oh, another very, very common use case. It used to be called the traveling salesman problem. And when I was in school, the traveling salesman problem was an intractable problem that you couldn't solve, but it's been solved many times over. What the traveling salesman problem is that you have to find the optimum route to go and peddle your stuff around wherever. So this is a problem that UPS, FedEx, the Postal Service, Amazon face every day.
Yeah.
It's a routing problem, and they use adaptive neural networks to solve it, to find the best path. So that's another example of that. Did that answer your question?
Yes.
Thank you. I don't know how to get rid of it. So, okay, rabbit hole. So let's go there. Let's talk about life. And when I'm not going to talk about the soul, and I'm not going to talk about anything that deep, but I am going to talk about how do we identify that something is living, and how do we know when they've taken us over? I guess is the question. So what you see on the screen right now is called the game of life. The game of life was formed by a computer scientist named Conway. And it's a pretty cool thing that has some practical applications, but many which are not practical at all. But what I want to point out is kind of how it works. So I have 3 separate generations of the game of life up on the screen. The first left one is the easiest to tell what's going on. So it's a game that has 5 rules, and they're all very basic. The rules say when something's going to turn from white to black, which means created, living. So all the black ones are quote-unquote living. When, under what conditions does something turn from black to white, which is death? When do they just maintain and reproduce? And that's it, really. Yeah. So they're all very basic. So if you have exactly 3, everything stays the same. If you have only 2 neighbors, then you die because there isn't enough resources to support you. If you have 5, you also die because there's too many squares competing for resources. So that's all it is. These each represent a generation, which is a snapshot in time. Okay? So that could be generation 1,000, that could be a generation 1,000, that could be generation 1,000. The top, is everybody kind of clear on how the game of life works? Don't overthink it. It's just black and white squares that alternate sometimes based on some sort of rules. But I think it is important when I talk about this. So the top left is random, more or less. You can see some patterns and so forth. If I were playing this in real time, you would see them move. I'm going to do that. Should have put con. Oh, there we go. I'm going to do the Wikipedia article because I know there's one. Okay, so you see in the bottom right-hand corner how it's moving? Each time it moves is a generation. So think of each of these black squares as a critter, and all of the black squares is a population of critters. And they're associating together like any community would, and there's some rules that they are created, there's some rules that they die, there's some rules that they maintain. Now, I noticed that on Wikipedia it never changes. So, which gets back to what I want to say on the slides here. This is relatively random, meaning it was probably started with 1 or 2 random dots somewhere, and this is what it became. The one on the right was also random, but if you're a computer scientist or you think it's actually very beautiful what happened here, because each of the diamonds is a community that's formed on its own, and they're stable. So in biology, this kind of looks like cells, but it's pretty remarkable that they did that on their own, randomly. So you might almost think that they're real, they're living. And then we have a cat. That cat was created because somebody knew exactly where to put the dots, that in 100 generations, they would get a cat. Now, the reason this is important is because, from randomness to discrete pattern, is it means I am able to tell this AI what it should be. So it's dictated, and it's living within the bounds that I created for it. So I, a human, determined what those bounds were, what the rules of the game were. This is very rudimentary, but obviously in the broader world of the things that could be in terms of intelligence, it gets much more complex. But by looking at a very rudimentary sample, we can start to ask ourselves, are these squares living? Right? And obviously we don't think they are because they're not aware of themselves. They don't have empathy. They don't even have intelligence because they are operating based on my rules, not their own rules. So, yeah?
So when they become cats, is the cell still evolving or cell pretty much stopped?
It evolved.
Still evolving.
No, it's not.
It's not.
In this case, this person figured out that it would hit a steady state, which sometimes happens. In this case, those diamonds are not
That's
changing.
evolving.
They've stopped.
It's not as well.
Yeah. Yeah.
Because instead of leaving, that's like the.
So sometimes, yeah, so that's what's interesting. Sometimes they stop. In the case of what I showed you in Wikipedia, it had what's called sliders that were shooting into the...
Yes.
Those always go in indefinitely. Yeah. It's actually, the game of life is actually very, very fascinating. But your point is very interesting because if it's truly random, if I start a random game, it could stop, it may not. You don't know.
That cat has several single black pixels, which will disappear in the next generation, so I don't see why that's fixed.
Yeah, it's their relationship to each other. They always regenerate in the same spot.
Right, and we can see single black spots.
You mean in terms of the cat?
Right, in the
Yeah.
next generation, they will not be there.
Yeah, you're
So
right.
the cat won't
You're right.
look like a cat.
You're right. Yep, you caught me. You're absolutely right. That cat would disappear in the next generation.
Right.
I didn't look at, obviously there's individual ones that would all die. So you know the game better than me.
Yeah.
So there's something called the Turing Test. Alan Turing is a famous computer scientist before there were computers, and he gave us some really great things. One of the things is the Turing machine, which is the best representation of the most minimalistic computer you could ever have. And it's very cool. All it does is move memory right or left, basically. And right or left, add or subtract. That's all it does. So it's a very cool thing, and he's showed that that simple computer could do anything. You could write any sort of program with that, no matter how complex. It just would be very difficult. Anyways, he came up with something else called the Turing Test. And the Turing Test is if you were presented blindly, so through a chat dialogue, with some sort of assuming living being on the other side, and for 5 minutes, could you have a conversation with this either machine or person and tell whether or not it's a machine? And he said, within 5 minutes, if you could say confidently that it's a human, then that machine passed the Turing test and is artificial intelligence. There's a lot of things wrong with the Turing test, even though it's referenced in a lot of sitcoms and in movies and so forth. Number one is it's rather obvious. It's stating that do you think it's AI? Then it's AI. I mean, it's somewhat trivial. Number two, there's a lot of things that, again, we trick ourselves, which is the anthropomorphic fallacy that if it acts human, we want to believe it's human. So if it acts like it's artificial intelligence or that it's intelligent, we want to actually believe, it's our propensity to believe that it is. So we will accept it in that way. The other thing is consciousness. Can you simulate that? And I want to go back to the movie, and I don't know if I wrote this down, but the robot in Robot and Frank passed the Turing test for Frank. I think we could all agree that at the end, what did he say? He is my friend. It's a very human thing. So to Frank, at the beginning, it was just a computer, but later on, it was something much more than that. The robot passed the Turing test for us. So if you felt the same way I did when they erased his memory, then he passed the Turing test for you, I would argue. But we know that if you really dissect how the robot functioned in that movie, that it wasn't intelligent necessarily. It was following a set of rules and programs. And so that kind of shows the fallacy of the Turing test, but also shows how subjective and difficult it is for us to actually say whether something is artificially intelligent or not. And there's other things that kind of fall apart when we try to figure out if something is artificial intelligence or not. Other than the things that we very matter of fact know, like Alexa and Google search and so forth. One thing is the fact that we created it. So I'm going back to the game of life. If a human creates the system, then the system is bound by what the human says. So in the game of life, it's very simple. And in the game of life, it's literally bound. It has a world that it can live in. And you write it so it's modulus, so if it goes all the way to the top, it comes up the bottom. It's bound. It's bound by rules, it's bound by location, it's bound by physicality. Everything that a human decided, not necessarily arbitrarily, but they decided it.
Yeah.
And if you think that this goes away the further you go down in complexity, it really does not. There's a, oh, it didn't end up on this, oh, thank you. It isn't here. So there's a famous mathematician who created the Incompleteness Theorem. And the Incompleteness Theorem says that basically any systematic thing that humans create will never be complete. It'll always have holes. And so I would argue that this is a serious problem when it comes to AI that kind of takes on a life of its own, is that it's living within the frame that we've given it, including the programming. Now you could argue once we get to the adaptive stage that that's different, and if we ever get to the living stage where it has empathy, self-awareness, and introspection, that those bounds might be transcended, but I'm not too sure about that. The other problems with creating true AI is use cases. We have one use case today, a button, right? That's cool. I think that that's a valid use case. Another use case I came up with is international spies. Let's say you want to send something that is very human out into Russia and make friends with high officials in the Russian government to spy. That's also another use case. But is that practical? Even though we probably could make a robot and Frank today, the cost of it would be remarkable. So it would only be for the richest of the rich, because it's not something that you can just mass produce. But also, there's a very kind of trivial thing that we have to figure out: infrastructure. So these types of robots imply a tremendous change to our infrastructure. The first thing is the internet. The internet speed that comes into your house, is probably reasonable. It probably could have as many of 10 megabits per second down, which is fast, and 1.5 megabits a second up. But that's too little for a robot and Frank. And I'm going to go through the mathematics in a second if you're curious. But it's so little that if the robot to operate needed to speak to the internet, it wouldn't be enough data transfer. So the first infrastructure change is all of our houses would have to be fiber optic, or the cellular traffic would have to be much, much faster. The next thing is batteries. We all know that the battery life on our devices is too little for us. Yeah. The core element of batteries today is lithium. Lithium is a limited resource. So until we produce better batteries, which by the way, there's a group at the labs working on that. I had a chance to talk to one of the scientists over there, which they haven't figured it out. They're trying. There's some interesting elements. Until we have better batteries, the robot and Frank is not going to operate for very long, given the amount of work that he has to do. So we have to invent wireless power. There's a lot of issues with wireless power, including radioactivity and disturbance and other things, even though that is possible as well. Data storage. So this one is very interesting that I'm going to go through in a second. And the human brain itself. So if this AI is to operate like a human has to be 1,000,000 times more powerful than your laptop at home. And that currently doesn't exist. And I know that back in the day, in the 90s, we had this concept of Moore's Law. I always get Moore's Law and the other one. Anyway, so the doubling of computing power. Well, as of recently, that is stopped. It's no longer valid. Computers have hit a flat line. If you notice that processor speeds haven't gotten much faster than they are today. And the real reason for that is size on the chips. Even though we can get smaller and smaller and smaller, the size of the chips, there's a limit. But actually, if you're familiar, so the CPU is what does the processing, and the disk is what stores information, right? Disks operate much slower than the CPU can write to them. So the disk in our computer is actually the limiting factor. And so now the disks have to get faster, and we're not there. So we're actually not moving as fast in terms of processing power as we were, and definitely not at the rate that we're going to get to the power of the human brain in any short time frame. But I wanted to go to storage. So these are all very practical, tactical reasons. Even if all the software and all the algorithms exist to make true artificial intelligence, these are part of the reasons that maybe they don't and won't in any near time frame. So you don't need to pay attention to the exact math, and you may or may not know what gigabytes and terabytes and megabytes are. But I went and did a thought experiment. I realize this is an old version of my presentation on how much data you would have to ingest if you're the robot in Frank. You have to ingest your visual field, everything you see. So we have a very good idea of how much data that is because of video cameras that can record and so forth. Smell, probably, right? Because you want the robot to be able to sense certain things that could endanger Frank. You would want temperature readings also. If the house is on fire, you want to help Frank, right? Olfactory is smell, and touch, sensory touch, for the simple reason that if the robot is facing that way, I don't want to get his attention, I can tap his shoulder and he'll turn around. Now, granted, there's probably some really cool things you could do to reduce the amount of data that all of these take. But the way I figure that even if you store, well, we're going to go with 100%. Let's say you store all of that data. You end up at 196 terabytes a year. And to give you a sense of what that is, it's probably the size of a small data center. A data center is a facility where all the big tech companies store all their computers. So Google, Facebook, they have many, many data centers. And probably the smallest one is 100,000 square feet.
Wow.
So everybody, if every human had a data center after a year, we'd be running out of land very quickly. But also, that's assuming that we use the cloud to store the information. So robot stores all of its data in the cloud, which is probably the way it would happen, instead of physically on himself. If he had to store it physically on himself, it'd just be totally impractical. So the only solution would be not to store everything. But in Robot and Frank, we know that he does because he replayed memories. He replayed the recording of the jewels. So he stored a complete video of that entire scene. So we know it was there. So we know that the internet's not going to support the transfer of all that data to the cloud. That storage of that data would be a tremendous amount of storage. So that right there, which is very kind of tangible thing, makes it very difficult. And actually, the algorithms to make the robot and Robot Frank to do all of the things he does in terms of how he interprets things and how he responds to you are totally there. They're there, they exist, and so forth. And the great thing about the movie, it's actually very realistic because the robot lived within confines. He wasn't trying to be something more than he is. He was aware that he wasn't, well, he can't be aware that you're not there. But he was a robot, so he's programmed. He said that it is part of my programming to build trust, etc. And for him, having his memory erased was no big deal. But for Frank, it was a very big deal. So that alone kind of shows you what's going on there, and all that facets of associated with memory in that movie was amazing. So that's why, you know, I think that we haven't just catapulted into that area and maybe can soothe some of the concerns now of them taking over the world. Now let me re-raise those concerns for you, because this is more a thought experiment than it is, like I said, an answer. So there's a movement called the Transhumanism movement. And this is replacing humans with robots, humans becoming robots. It's all of that good stuff. And I put several of the figures on there. Ben is the gentleman who I've interacted with a lot when I was a part of the advisory committee for the Singularity Institute, which eventually became Singularity University. I was only on it for 2 days, and there's a reason for that. But at the top, there's Ray Kurzweil and Aubrey. And both of them are transhumanists, but they're both transhumanists in kind of a very discrete... Are we okay for time? Is there...
Yeah, you know, we got maybe 10, 15.
Okay, sorry. Is everybody okay? I don't want to...
we're fine. Yeah.
Okay. I was hoping to get here faster. So, Aubrey and Ray Kurzweil are both on different wavelengths and agenda. They're both transhumanists, but they're both going after a different path. Okay? Ray Kurzweil is an important figure in everybody's life because he's the inventor of optical character recognition, which, whether you realize you're using it, you're using it. It's what we talked about before. It converts text into, or converts images into text. So his whole thing is that we are going to download our brains into software. So we're going to convert ourselves into programs. And he has this whole fancy explanation of why we can do this. And for the most part, it's totally valid. You freeze yourself, put yourself in a scanner. The scanner scans your brain. It takes every neuron in your brain, converts it into a software neuron, connects them all together. The connections are actually the hardest part. You unfreeze yourself, you start the program, and there's exact copy of you. Now, one of the serious issues with this is, let's assume that happened, and you're staring at a terminal, which is now you, and you are you. Which one is going to claim that it's the real you? So there's a very serious issue, and he concedes to this issue as well. In Ray Kurzweil's world of artificial intelligence, the physical world goes away. There is no physical world, which eliminates all the problems I said before about robotics, trying to store physical information. We are all interacting with each other as programs, not in a physical world. So that changes everything in terms of the paradigm of what could be. Aubrey is different. Aubrey is looking at it from a biological level. And he is actually living his life and taking pills that he's created and doing all sorts of crazy things to do what he believes is make himself live forever. And so that's interesting. It's purely from a biological level. So transhumanism is not the same as extension of life. Transhumanism is living forever. So Ray Kurzweil's going to live forever because he's a program. Aubrey's going to live forever because he changes the way our bodies operate. Life extension is something different, and the scientists that work on life extension are trying to solve a different problem. They're trying to alter your makeup when you're born so that as you age, you have a better quality of life as you age, so that you don't face a lot of the ailments that happen to you later in life, and you have a better quality of life, but decay still happens, and once you end up dying, it's a lot more comfortable. So that is life extension, and they're looking at DNA repair and all sorts of things for that. So transhumanism is not necessarily AI. I understand. What Ray's doing is definitely AI. But it is in this category of life and changing the way I live. And you notice that I'm not really talking about robotics. Again, going back to the point is that what actually might end up happening is not necessarily in the form of robotics. We will have the robots and Robot and Frank supporting various aspects of our lives, but they're not going to take over the world, in my opinion. Mostly because if we ever get there, the physical world will be augmented with software. So the physical world itself may kind of take a back seat. There's many movies, but movies like The Surrogate and so forth. So here's my opinion. I'm a big fan of AI, but I'm also very pragmatic about what it is and how it's used. And the way I use it and my company is in a business sense to improve workflows, to improve the efficiency of how people work, to improve how people make decisions. That's the most common use of AI. But I firmly believe that AI, artificial intelligence, and humans will always be integrated, which means that it's not artificial, it's just intelligence, it's us. And that's always been the case, actually. All of the transparent technology, how we use the internet today, how we are augmenting ourselves with smartwatches. This is the same as becoming a cyborg. Contact lenses. All of these things are technologies. They may not be computer technologies, but they're technologies that are extending our life and changing the quality of life. And I think that that's going to be the progression. And I think that how this is going to evolve, you won't even really know. It's going to be like getting a contact. When you get a contact, you don't realize that you're modifying the way you live into the future. You're just going to adapt it, and it's just going to become part of you, and it won't necessarily be artificial. But because we are a part of it, we are fully integrated with this technology, it's not a matter of us it taking over the world and learning beyond us and starting to manipulate us like in the Matrix. I think that the most advanced AI is not going to come in a human form. And the anthropomorphism is not the most important thing. I think the most advanced UI even today, the one that gets our attention is the robots and Frank, but hopefully, as I've illustrated, that's not the most advanced AI out there. The most advanced AI is when you do a Google search and you don't even realize it's happening. When you make a cell phone call and that call is routed to my family in Colorado, and that route changes many thousands of times a second, that's AI. And we use it every day, and we're not offended or turned off by that, or maybe some of us are terrified, but we're not terrified by that. We use it every day. And so I think that that's interesting to know and to remind yourself that that's already taking place. There is mind-blowing technology already here, and technology that is far beyond, or far from being consumerized, but things that we can do. Teleportation, for example, they've teleported single cells in an individual office. So there's crazy things out there, no doubt. But for a crazy thing like that to become practical, there's a lot of economical infrastructure things that have to happen first that I think we forget about. We need the Ray Kurzweils and the Aubreys of the world, not because they are there to frighten us, I guess, in a way, but not because what they say is actually going to come true. It's the same reason we go to space. There isn't a lot of practical value of going to space and having to us here on Earth. But it pushes the envelope enough that eventually we learn something new that we can apply on Earth. And so that's why those people exist. And I don't think that what they're professing there is coming anytime soon. There's a lot of problems with Ray Kurzweil's brain scanning. Another one is how do you make sure that you stop your brain, completely, so that you can download it, because it has to be totally stopped. If it makes any sort of change when you're scanning it, it would disrupt the program version of you. So that's where I'm in. Now, if you want to be afraid, and this is my opinion, Google is probably one of the most we don't think of them as a secretive organization, but they actually are very secretive. I don't know if you've noticed that Google is now an entity, a part of Alphabet Inc.
Yes.
So they split themselves up before they were forced to split up, but in doing so, they maintained their integrity. Has anybody ever used Google's language translation? So what's interesting about that is that they did not teach a program what language was. All they did was use their vast amounts of information and really good statistical analysis and our neural networks to do the translation. So from the point of view of the software, it doesn't really know what the language is, like other language technologies that preceded it was you teach it language, you teach it nouns, verbs, etc. It doesn't need to know that. It has a database of so much information that it can take all the forms of a single document and then when you search, present those back to you. So they have so much information and this is a little bit conspiracy theorist, you have to forgive me for that, but I guess if I wasn't sharing my opinion, I'd be going nowhere. Things like Google Plus is probably something that you may have registered for, but Google uses that a way to collect more information on you and your behavior. They don't really care whether you use it or not. They're trying to profile you. All of this is feeding into DeepMind, which is their artificial intelligence. Now, I suspect that DeepMind is severely lacking adaptability, severely lacking empathy and self-awareness. But if you were to ask any question in the world, it would know the answer and it would give it to you in a very human fashion. And so this is where probably the most amazing artificial and potentially scary artificial intelligence has come from. Fortunately, they report to a board and investors, and it costs a lot of money. So if they're not starting to profit from this, then it's an issue. So I went rather long, and I hope this was useful, and I'd be happy to talk to you after, or we can